morning students. I welcome back you all to this mathematics class, and we are discussing here class 12th probability, and today we are going to continue with exercise 13.2. We have already discussed question number 1 to 6 or the important questions from 1 to 6 of exercise 13.2, and here we have question number 7. And this question says that A and B are two events such that probability of happening of A has been given to us to be 1 by 2, and probability of happening of B is some unknown constant P, and the probability of happening of A union B is 3 by 5. So we have to find the value of this P. This P is unknown and it is to be found in two cases. Case 1, when A and B are mutually exclusive. You can see we are doing first part 1 first. So when A and B are mutually exclusive, that means that their intersection is 5. The meaning of two events being mutually exclusive means that they have no common element. So this implies A intersection B is 5. A and B have no common elements. So A intersection B is a null set, and that means the probability of happening of this is 0. Since this event A intersection B is not containing any element, so the probability of its happening is 0. So now I already know the formula A union B. If we write that, this is equal to probability of A plus probability of B minus probability of A intersection B. So I had to write here A intersection B. So now I substitute all the values. Probability of A union B has been given to me to be 3 by 5. Probability of A is 1 by 2. Probability of B is unknown P, and probability of A intersection P is 0. So I can find out the value of P, which is going to be 3 by 5 minus 1 by 2. So we solve this further, take the simple LCM, and it comes out to be 6 minus 5 upon 10. So the value of P comes out to be 1 by 10. That is the probability of happening of the event B is 1 by 10 in this case. Now we move to the second part of this question, which says that probability of A and probability of B and A union B, they are same as in first part. But what is important is that the events A and B are independent here. So once the events A and B are independent, therefore they are going to follow this, that probability of A intersection B should be equal to probability of A into probability of B. This is the condition for two events to be independent. Now again we apply the formula of A union B, which is equal to probability of A plus probability of B minus probability of A intersection B. Now students, we already have all the values. Probability of A union B is 3 by 5. Probability of A is 1 by 2. Probability of B is unknown. And probability of A intersection B will be probability of A into probability of B. And therefore, we write all the values. 3 by 5 is equal to 1 by 2 plus P minus. The value of probability of A is 1 by 2 and the value of PB is P. So that gives me 3 by 5 is equal to 1 by 2 plus P minus P by 2 becomes P by 2, and now I can find out the value of P by 2 also. So that gives me that 3 by 5 minus 1 by 2 is the value of P by 2. This we had already calculated above in first case. This value came out to be 1 by 10, and you can cancel 2 with 10, you get 5, and this implies that the value of P comes out to be 5 in this case. P was the probability of happening of B, so this is 1 by 5. Now we move to question number 11 of exercise 13.2, and here we can see that it is given in the question that A and B are two independent events. Probability of happening of A has been given to be 0.3 and probability of happening of B has been given to be 0.6, and second thing, it is given that A and B are independent, and we have to find the different in every case we have to find a different value. First case we have to find the value of probability of A and B, as you must be knowing from the knowledge of sets that A and B means A intersection B. So now since you know that events A and B are independent, therefore P of A intersection B will be equal to PA into PB. So probability of A is 0.3 and probability of B is 0.6. So we multiply them and we get the required probability to be 0.18. Now in question number 11, second part of this question, we have to find out probability of A or B. Probability of A or B means probability of A union B, and the formula for finding this probability is probability of A plus probability of B minus probability of A intersection B. Now students, we already know that probability of A has been given to us to be 0.3, probability of B has been given to us to be 0.6, and right now in the first part we have found that probability of A intersection B is 0.18. So if we add 0.3 and 0.6 we get 0.9, and I can also write 0.9 as 0.90 because you know after the decimal you can take as many zeros as possible. So 0.90 minus 0.18, that gives you 0.72. So the required probability is 0.72. Now we have the next part in which we have to find probability of A and not B. To understand this, let us consider this figure in which U is the universal set which is represented by this rectangle, and A and B are any two sets represented by these circles. Now I want to understand what is A and not B. So A and not B is basically A intersection B complement. So now you see, if I take B complement, that will be the whole portion of the universal set except B. That means everything outside this green circle is included in B complement. And if I will take its intersection with A, that will give me this portion. This shaded portion gives me A intersection B complement. And this shaded portion is also represented as A minus B. So probability of A minus B means A but not B is given by probability of A minus probability of A intersection B. Now probability of A is 0.3 and probability of A intersection B is 0.18. Now 0.3 can be written as 0.30 and you subtract and you get 0.12. So this is the required probability. Now next we have to find the probability of neither A nor B. This means we have to find A complement intersection B complement. We have to find the probability of this set. Now I use the De Morgan's law. So in case if you people are not familiar with De Morgan's law or you have forgotten it as you studied it in your class 11, so let me revise. De Morgan's law states that A union B whole complement should be equal to A complement intersection B complement, and there is one more statement to it, that A intersection B whole complement should be equal to A complement union B complement. This means that whenever you distribute the sign of complement over union, it becomes intersection, or over intersection it becomes union. This law is going to be used here. So according to the De Morgan's law, this is probability of A dash intersection B dash becomes probability of A union B whole dash. That means complement of A union B. Total probability is always taken as 1. So this is equal to 1 minus probability of A union B, and we already know that probability of A union B is 0.72. So 1 minus 0.72 will give me 0.28. So So this is the required probability. Now we have question number 12 of exercise 13.2. A die is tossed thrice. When you toss a die 3 times, the sample space consists of triplets of this kind. It can have all the same number, all the 3 numbers same, or it can have different numbers. Any 3 numbers out of 1 to 6 can be at the place. So you will be having such kind of triplets at sample space. And how many elements will be there in sample space? 6 into 6 into 6, that is 216 elements will be there in the sample space. Since you have one die has got 6 phases, and on each phase there is a number written 1, 2, 3, 4, 5, 6. So in one toss you can get any of the 6 numbers. So 6 ways of filling every place. There are 3 places, so there are 216 total possible number of outcomes. You have to find the probability of getting an odd number at least once. So if we do it this way, that from the total probability, if we subtract the probability of getting all even numbers at 3 places, so what we are doing is that we are subtracting the probability of getting all those triplets in which we get all 3 places even, like 2, 4, 6 and different permutations of 2, 4 and 6. Then that will be the required number, that will be the required probability in which you will have only those cases where at least one number will be odd. So since we know that out of 6 numbers, probability of getting an even number is 1 by 2. So 1 by 2 is the probability of getting one even number at one place. 1 by 2 is the probability of getting an even number at second place, and 1 by 2 is the probability of getting an even number at the third place. So we get 1 minus 1 by 8, that is 7 by 8. Now we have question number 14 of the same exercise. There are two people, A and B, and the probability that A solves a particular problem is given to be 1 by 2. And the probability that B solves the particular problem is 1 by 3. And the next thing given to you is that A and B are independent. Then question says that both of them try to solve the problem independently. You have to find the probability that problem is solved. Now here, the problem, to find the probability that the problem is solved, the problem can be solved by either A or B. So that means you have to find the probability of A or B. A solves or B solves, which is equal to probability of A union B, which is equal to probability of A plus probability of B minus probability of A intersection B. Now here, in this case, since we know that the events A and B are independent, and therefore probability of A intersection B can be written as probability of A into probability of B. Now I can substitute the values of probability of A and probability of B. Probability of A is 1 by 2, probability of B is 1 by 3, and here also we substitute 1 by 2 into 1 by 3. Now we can solve it. So the LCM is going to be 6, 3 plus 2 minus 1, 5 minus 1, this is 4 by 6, that comes out to be 2 by 3. Now second part of the question is, find the probability that exactly one of A and B solves the problem. This means probability of either A solves and B not solves. This can be the first case, or the case can be A not solves and B solves. Since we want only one of them should solve, so if A solves, then B does not solve, and if B solves, then A does not solve. A solves means probability of A intersection. B not solves means B bar. Or means you have to add the two cases. Probability of A not solves means A bar, and is translated to intersection. B solves means B. So we have to find this probability. Now since the two events A and B are independent, so A and B bar will be independent, and A bar and B will also be independent. That will give you probability of A into probability of B bar, where B bar is same as B complement, A bar is same as A complement. This is equal to probability of A complement into probability of B. Now students, look here. As we know, probability of A is 1 by 2. So probability of A bar is same as probability of A complement, which is equal to 1 minus probability of A, which is equal to 1 minus 1 by 2, which is 1 by 2. Similarly, as you know, probability of B is 1 by 3. So probability of B bar, which is same as probability of B complement, which is 1 minus probability of B, that is 1 minus 1 by 3, that is 2 by 3. So we are going to use these results, and in place of probability of A, we write 1 by 2. Probability of B complement, we have calculated 2 by 3. Probability of A complement 1 by 2, and probability of B is 1 by 3. So again here we get that the LCM is 6, and in the numerator we have 2 plus 1, which is equal to 3 by 6 or 1 by 2. Now we have question number 18. It is an MCQ. Two events A and B are independent. So it is given to you that A and B are independent. So probability of A intersection B should be equal to probability of A into probability of B. But there is a result that when A and B are independent, then A complement and B complement are also independent. So we get a result from this. Since A and B are independent, and therefore A complement and B complement are also independent, and therefore P of A complement intersection B complement, which is same as A dash B dash, should be equal to PA dash into PB dash or complement. But probability of A complement is 1 minus probability of A, and probability of B complement is 1 minus probability of B, which is the correct option B. Now with this question, I end up this video. Till then, keep revising, keep studying, and don't forget to like, share and subscribe this channel.